Well, thank you, Mark and Martin. It's great to be back in Budapest. This is something that I've been able to do every year that that the Openstack Day has happened here, except for once when I had a flight that got canceled, and I was stuck in Paris, which is a nice city, but it's not Budapest. So I'm sitting by my French coworker down here, so we can get his opinion on this in a little bit. So thanks everyone for coming, and thank you to the community organizers who put this together. As I said, this is a community event, but it's something that is connected to this global OpenStack movement that we're part of. And this morning I wanted to talk a little bit about kind of what we see happening within the OpenStack community overall. Give you a little bit of an update on some things that we talked about just a couple of weeks ago in Vancouver at our most recent OpenStack Summit, and then talk about some of the actual activities that are going on. So the first thing is, what are we as a community? We started out in 2010 as about 25 developers with 18,000 lines of code in two projects, Nova and Swift. And since then, it's grown to something that's almost 100,000 people in 180 countries, millions of lines of code, and it looks very different from those early days. But one of the things that I think we've realized that really defines us is, as a community, we are people who build and operate infrastructure. We are building technology and running it in ways that are really kind of core to a lot of businesses, a lot of the things that we interact with in our world on a day-to-day basis, and that's something that I think really defines us as a community. And also, we do that with open tools, with open technology. So we build and operate open infrastructure. And a lot of times, we talk about building, especially that's what we talked about in the early days as we created a very large and active developer community. But more and more, I think that the operate aspect is becoming extremely important to what we do and to what we need to think about as a community. You build software so that people will use it. we build infrastructure software so that people will operate it and run their businesses with it. And we see that across all kinds of industries, planes, trains, and automobiles, as the old movie goes. And this is something that is happening all over the world. These are our data points from different community metrics where we have deployments, and you can see that it spans the entire globe now. And it's used for things like science. These three images are from a cancer research center in Canada, CERN, which we'll hear from Tim, and just like Martin, Tim's talks are always some of my favorites to hear what they're doing with all of the data produced by the Large Hadron Collider, and also the Square Kilometer Array, which is a new science instrument that is coming online over the next few years and is also integrating OpenStack as a key component. And we see it in commercial industry as well, with retail, with banking, with insurance, with every industry pretty much at this point. And people are taking OpenStack and they're running it in all of these different use cases and all of these different environments, and they're doing it for a lot of different reasons. In some cases, it's because of cost. I mentioned the Cancer Institute in Canada. They moved from a commercial offering to OpenStack and saved 40%. There are different e-commerce companies that we've talked about before who have moved from public clouds to OpenStack and saved 70%. So cost is, definitely a big factor. It comes up very high in our user survey in terms of why people choose OpenStack. Another reason why is because of compliance. If you have regulations that enforce where you can store data, where you can run your servers, a public cloud may not be an option for you. You might need to run that yourself. You might have data compliance laws, data sovereignty laws that I know are at play here in Europe. And so, different reasons come into play. But one of the things that I think we've seen really happening within the cloud industry overall is kind of like I was talking about earlier. OpenStack started out very small and with just a couple of projects, and has expanded over time. And what people want to do with their clouds started out basically with just virtualized compute and has expanded over time. People want to do more with their clouds now. They don't just want virtual machines, they want containers, they want serverless functions, they want to be able to do machine learning and AI, they want to do it in more places. It's not just about having it in a big data center somewhere. This is the trend that we've seen a lot in terms of deployment models is moving from just massive clouds inside of central data centers to deploying it in more and more locations, even out to the edge. So one of the things that I think is a myth that goes around sometimes is that the cloud is consolidating, that cloud is getting more and more uniform and it's going to all end up in just kind of a handful of public providers. But when I look around, what I see is not just a bunch of commodity x86 servers that are being turned into virtual machines. I actually see a lot of diversification that's happening in the cloud space. And that comes from those use cases, that comes from those deployment models, it comes from architectures. Within Openstack, we support a variety of different compute hardware architectures now. It's not just x86, but also Power has been around for a while. ARM is more and more supported. There are accelerators with GPUs and FPGAs. I think we're going to hear about some of that from Genesis in a little bit. And another area where there's a lot of diversification is in the technology choices that are being used. At the Openstack Summit in Vancouver, just a couple of weeks ago, we had sessions from dozens of different open source communities that came together there. And we call it the Open Infrastructure Summit a lot of times through the week, because it's true that nobody runs any one of these projects. Nobody just runs OpenStack or Kubernetes or Spinnaker or pick any of these names. They combine them together. And so we see that diversification happening everywhere around us. But one thing that I think I also see and hear a lot is that people really are drawn to open solutions. And there's a sense that open source and open collaboration is the best way to solve our hardest problems. And if you look back to some of those trends that I was talking about, when you look at things like machine learning, all of the top machine learning frameworks started out as open source projects. And if you look at the container space, where you have leading projects like Docker, Kubernetes, Mesos, those all started out as open source projects. So people agree that collaborating on these hard problems is the right way to do it. But I think also that one is not enough. There's not one project, one provider, one foundation, one way to solve all the problems that we face. So we need to have it. We need to have it open. We need to have all of these projects, but we have to think about how do we take that open source and turn it into something that we can run as open infrastructure, because open source is not enough. And how many of you are involved in running a cloud? Okay, so about half. Cool. So I'm sure that you have you've learned a lot through the journey of running a cloud. It's not something that is that's just a point and click kind of operation. There's a lot that goes into taking software and running it as infrastructure. There's a lot that goes into taking open source and turning it into open infrastructure. And to me, that's where our biggest opportunity as a community lies right now. It's to take all of these tools, to integrate them, and to make it so that we can operate these tools as open infrastructure. So I mentioned some different industries who are doing that today with OpenStack, but I want to talk about some specific companies as well. These are some OpenStack users that have been around for a while. And what's interesting is if you dig into each of these use cases, they are all using multiple technologies. A lot of them are using technologies like Kubernetes or Cloud Foundry to add a layer on top of their cloud IaaS environment. Others are using open source networking tools like eBay, Walmart. Some of them are using TensorFlow and Caffe and other machine learning tools. But they are all doing this today, where they're taking these open source tools and running their businesses. But I think that one of the really important points to remember is that logos don't operate clouds, people do. And that's why events like this are really important. If you are here and you're trying to think about what you should do with OpenStack, what you should do with your environment, find one of those people who raised their hands a minute ago and ask them what they've learned in running their clouds. And we have great operators all over the OpenStack community. This is a team from Adobe. They spoke in our Sydney summit last year, and these 4 individuals, they run a pretty large OpenStack cloud, has over 100,000 cores, and it does a very large amount of traffic for the Adobe Marketing Suite. That's a software as a service product from Adobe. So those 4 guys are operators. This is Eli Elliott. He runs OpenStack and Cloud Foundry for the Gap stores, which is a retail clothing chain. And Ricardo Rocha spoke at our most recent summit in Vancouver, and he works at CERN with Tim Bell. And we'll hear more about what they're doing, but one of the things that I think is really interesting is they run about 200 Kubernetes clusters on top of their OpenStack environment. And they also federate that into public clouds in addition to their private clouds. So these operators are really key, and we have an incredible number of them in this global community of ours, and they provide a lot of experience, a lot of information, a lot of knowledge that I think one of our goals as a community should be to take that and to make sure that we are finding ways to incorporate that back into the software, but also to share the knowledge so that everybody can learn from what they've been doing. The other thing that I think is an interesting point to note is that we're seeing that operators are also builders. Many of those operators that I mentioned, they contribute to the community in some ways, and you might have recently heard from the OpenStack Summit that there are some new tools that are getting launched over the next few months. One of them is called Airship, and that's a tool that has come out of SKT in South Korea and AT&T, and it's a set of tools to containerize and operate open infrastructure services. So it supports Kubernetes and OpenStack right now, and can support other tools along the way. It's just getting started. You can check out some of the early code and early docs at airshipit.org. But this is an example of companies who are operators that are building the tools they need to combine, to integrate all of these open infrastructure pieces and make them something they can run. So it definitely takes community to do all of this, and at the OpenStack Foundation, one of our main roles is to help organize the community and help to kind of get us all working in the same direction so that we can accomplish bigger things together. In Sydney, about 6 months ago at the previous OpenStack Summit, we announced some plans that we had for really focusing on integration and open source. And as we've talked about, there's been this explosion of open source technology, but in a lot of cases, those tools are developed independently by different communities, different developers, different roadmaps, different release schedules, and that can create a lot of work for users and for operators to do when they want to put them together and make use of them. And so we saw that as an opportunity to go in and help people with integrating these tools together. And we identified 4 steps for integrating technology. And I'm going to run through these briefly. Thierry, who's going to be speaking next, is also going to talk about some of the specific things that we're doing at the OpenStack Foundation. But the 4 steps are, first, you find common use cases between different technologies. So if you think about OpenStack has always integrated different components like KVM for virtualization. A lot of people use Ceph for storage. One of the biggest areas of integration right now is in the container space. People are wanting an environment that provides virtual machines, bare metal, containers, all in kind of a unified way on the same network with access to the same storage resources. And that's what a lot of people are doing with OpenStack, but that's been, again, knowledge that has been kind of siloed between different groups. So we've been working on identifying the use cases there, one of the really common ones is Kubernetes on OpenStack, and a number of people in the community got together and recently produced a white paper that you can find on openstack.org/containers that goes into a lot of detail about how you can build that kind of unified environment, what the different networking models and networking choices you might make are, how you manage identity and authentication across all of it. And so those use cases are really important. And then once you identify use cases, a lot of times there are areas where you need to improve the collaboration between different communities. And again, going with the previous example, in the last 6 months, we spent a lot of time working with developers from the OpenStack projects and developers from the CNCF projects, like Kubernetes and Helm and some of the other ones, to find ways to make the integration between these tools work a lot better. One of the areas that I think there's been a lot of progress in is around the cloud providers in Kubernetes. This is something that has been restructured recently in the Kubernetes community, and a couple of OpenStack developers have been very key in kind of helping them figure out how they should manage that going forward. And that results in better code on their side, better code on our side, and a way that users can really use these tools more reliably and more scalably together. But sometimes there's actually a technology gap, and there's space for new technology to be created. And in that area, in the last 6 months, we've done quite a bit of work as well. Within the OpenStack software itself, we had our Queens release, and that included some really cool integration components around networking and the Courier project. I think there might be a talk on that here too. We launched a new project called Kata Containers, and I'll talk about that a little bit more. And also we established the Zool CI/CD project as something that's not just a tool for OpenStack to use, but something that people in general can use to do gating and testing on their software development process. So a lot of work has been done around this new technology area, and we have more that like Airship that's coming over the next few months. And finally, once you've kind of seen how things need to work together, you've done work in the communities, you've created new technology, you actually have to test it on an ongoing basis to make sure that it works and continues to work as those code bases move forward. And in that area, there's a community effort called Open Lab, and Open Lab tests common configurations of open source projects together and provides kind of an ongoing status around the combinations of those tools. And through this testing process, it's identified a number of different updates that need to be made in some of these core open source tools that people are using together, where they out of the box they just don't always work perfectly. One of the updates that happened during this last cycle too was the addition of OpenStack into the testing for the CNCF. So now the OpenStack software is tested as part of the ongoing development process of these CNCF projects. So if we dive into the progress of the technology that we manage within this community, I think one thing that's good to hit on briefly is an update on the OpenStack core software. We do have a lot of new things going on, but at the core of all of it is the compute, storage, and networking components from the OpenStack cloud software. And what we see there is continued growth, very rapid growth in user adoption. Last year when we did our most recent version of the user survey, we saw 90% growth year over year in the number of OpenStack deployments. So there's a lot of growth happening out there. One of the things that came out recently was a 451 research report that said among service providers, 71% were in production or going into production in the next 12 months with OpenStack. And if you look out over the next 2 years, it's actually over 80%. So adoption of OpenStack has really hit this inflection point where it's rising, and that's driving a lot of usage, and as we heard earlier, it's driving also demand for experienced operators, for people who can run those clouds. On the commercial side, we also see that market growing very rapidly too. This is from an IDC report, and the opportunity in 2018 for for OpenStack products and services is 6.1 billion. So that is a very large market size for an open source technology, and you know these are the markets that our sponsors here and around the world are going after, but we see a lot of growth in this as well, and this report predicts that it's going to continue to grow around 10% a year between now and 2021. And so that is another good sign for kind of OpenStack adoption and where we see that going. And then 10 million cores is the most recent OpenStack user survey data that we have for how many processors are being managed in an OpenStack environment. That's a lot of compute power out there. As we look at the software, I mentioned the Queen's release. The Queen's release saw some really cool updates in it. I mentioned the networking stuff with Courier earlier. It also had the first support for vGPUs in Nova. So as the GPU world continues to grow within data centers, the GPU manufacturers are building in virtualization support into their chips, and Nova now has the ability to provision those as resources within your cloud and within your virtual machines. There's also a project called Cyborg that supports accelerators in general, not just vGPUs, but also physical GPUs, and manages the life cycle around them. From an operations perspective, there were a couple of big updates that have been coming in. One is called fast forward upgrades, and this is the ability to quickly move through multiple upgrades. So the OpenStack community overall has supported an upgrade from one release to the next release. But as an operations team, you may not want to upgrade every 6 months. You may want to upgrade every year or every 2 years. And that was something that was pretty difficult previously, and it is now supported through this fast forward upgrade process. And I think that's a big win for operators. Another one is with a new policy around extended maintenance. And this is actually retroactive to the Okada release. And what this allows is for stable releases to then be maintained under an extended maintenance policy for longer than the 18 months that used to be the existing policy. So again, if as an operator you don't want to upgrade every 6 months or every year or every 2 years, you have the ability to backport security fixes and major bug fixes into a maintenance branch for as long as that is worked on by the community. So these are our big goals and big improvements from an operations perspective. And one of the things that the TC within the OpenStack community does is they set multi-project goals that are for supporting things like extended maintenance, for reducing technical debt, for improving the operator and user experience. And so this is a good place to get involved with the OpenStack community if you want to participate with the TC, propose goals, see which goals are out there, and help to work on those. Those are things that can really help move the software forward. Thierry's going to talk more about this, but this is a map that we started producing last year, and you can find it at openstack.org/software. And it really helps to lay out what the OpenStack projects are and where they fit overall inside of a cloud. So that's kind of the OpenStack project. I want to move on to the Zuul project. So Zuul is a new top-level project within the OpenStack Foundation, and it's focused on CI/CD. But Zuul isn't a new code base. It's been around for years. It's been around for 6 years, and as Jim Blair says, it's quietly been running one of the world's largest CI/CD systems. Zuul is what we built and use to manage all of the code process in OpenStack, and it's handled hundreds of thousands of changes, testing them in an automated way, and preventing broken code from ever even landing in the tree and getting into our source repositories. So it's a really cool scalable system that's been used by OpenStack, and it's also started to be used by other companies like BMW and Wikimedia, GoDaddy, and various other companies who want to kind of apply that same approach in their environment. And basically, the way to think about it is that it's a CI tool that is focused on gating. And gating means that code gets tested before it lands into your source repository. So you might be familiar with the term breaking the build, when a developer pushes code up and it breaks the build and other people can't continue to work. Zuul prevents that from ever happening by testing before the code is accepted. So it's a really powerful concept for an active and global and diverse developer community like Openstack, but it's also useful for anybody who just wants to make sure that their software is always buildable, is always production ready. And it does this in a way that is it's based off of Ansible. It's very pluggable, so you can use Ansible jobs to test your code before it merges. That are the same Ansible jobs that you would use to push your code into production. So you can have a really good alignment between your development process, your operations process, and make sure that everything is tested. And it supports Gerrit, which is the tool set that we use for OpenStack, but it also supports GitHub. And what's really cool about it is you actually can build a pipeline that connects both Gerrit repositories and OpenStack and GitHub repositories and other communities, or within your own code bases. So this allows you to set up full testing across multiple projects that might be using different repositories, different review systems, and have that testing all integrated in. So this is again, I think, a very powerful tool for that integration goal that I keep talking about. It's one of the only tools out there that allows you to do that, and it's open source and free software and follows the 4 opens. So I mentioned that it's not new. They recently had their V3 launch, which brought in a lot of that support for GitHub and for other cloud providers, and it's something that we're starting to see other organizations pick up and look at. So this is a really cool set of capabilities that we're excited to have kind of standing alone as a project. It's getting used by Open Lab to do that cross-community testing that I was talking about, and I think that there are a lot of other ways that it can be used. The other one that I wanted to talk about was Kata containers. And so Kata containers is a container isolation project, and the tagline for it is the speed of containers and the security of VMs. So what does that mean? Well, in pretty much every public cloud environment, they run their containers inside of virtual machines. If you talk to the major public cloud providers, that's what they do. If you talk to OpenStack public cloud providers, that's what they do. And in a lot of organizations, especially organizations that have compliance regulations, they still run containers in virtual machines in order to pass audits. But a virtual machine is traditionally very heavyweight, slow. It takes a minute or more to start up. It has a lot of overhead, and it ends up removing some of the benefit that you get with containers in terms of the lightweight overhead and the very rapid spin up and spin down with them. What Kata containers does is it creates this micro virtual machine that's extremely lightweight, has a very small footprint, and starts up still in under 100 milliseconds. So you are getting startup times that are pretty close to containers. You're getting overhead that is pretty close to containers, but it is fully isolated, and it can even make use of hardware extensions inside of the processor chips or memory, depending on what architecture you're running on, so that you can have full isolation and security all the way down. This is a new project that we launched in December, and it actually came from 2 existing projects. The hyper.sh runv project was one of them, and then the other one was Intel Clear Containers. And they merged their code bases and brought in kind of the best features of both systems and worked over the last 6 months to integrate those and do their first release. And so they just had that last week, I guess 2 weeks ago now, the 1.0 release of Kata containers. And it's been a really interesting project to be a part of for us at the foundation as well, because it's brought in new companies and new developers that haven't traditionally been involved in OpenStack. If you look at the architecture committee, for instance, it has Intel and Huawei and Hyper who've been involved in OpenStack before, but it also has representatives from Google and Microsoft and their public cloud teams who participate in Kata and who help to set the architecture and drive the project forward. So this is also a really exciting project. And when we talk about integration, to me, Kata is a really important project on that point, because clearly containers have tons of buzz, have a lot of rapid adoption, but there's also concerns about networking and security, and how do we manage that over the long term. Kata is one of the things that I think helps fill some of the gaps in there and answer some of those questions, especially around security. So you can find out more about that at katacontainers.io. And the last thing that I wanted to talk about was, I mentioned edge computing earlier, and I know that there are a number of people from around here who are working on edge computing and have been working in the edge computing group with us, but this is something that's come on the scene pretty quickly. Really just in the last year or so, we've seen a number of different things within the Openstack community that have kind of created a lot of momentum around edge, and thinking about how do we use Openstack and other open technologies to drive edge deployments. What I think is really cool about this is that this is truly a collaboration. It's across a lot of different companies. It's across a lot of different industries. Edge is not just about telecom. It's also about industrial IoT and manufacturing environments. It's about retail, where you have thousands of store locations that need to have some amount of computing power in them, satellite communication, textile factories, on and on. And it's also a great example of one of those places where it takes multiple communities. It takes the standards bodies, it takes the open source communities, and we have to combine these tools together to really deliver kind of on the promise of edge going forward. So this is something that's been moving rapidly, but it's still pretty new. And if you go to openstack.org/edge, you can find out some of the ways to get involved. There's happens to be one of those local people, Ildiko Vancha, who works for the OpenStack Foundation. She's right down here. And she is coordinating a lot of the edge efforts and leads a weekly call that goes over the progress of the edge group and talks about different things. One of the topics that they're going to be talking about next Tuesday at the next call is another new project that's just getting kicked off called Starling X. Starling X is the open sourcing of code from the Wind River Titanium product, and it's very early. It's something that was just beginning to be talked about during Vancouver, but it's something that's been used in production in especially industrial IoT environments, and has some interesting concepts around latency and performance and high availability. And so that's one of the many things that's happening in the edge space. But this is I think a really cool use case for OpenStack that a few years ago we never would have thought of as something that would be a use case for it. So what I want to just repeat in closing is there's tons of stuff happening in the open source world, and there's a lot happening in the OpenStack community, the OpenStack Foundation. But I think that our biggest opportunity is to look at all of that and find ways to take those open source tools and make it possible to turn them into open infrastructure, so that more and more of us can run these open systems to power our businesses and do awesome things in our organizations. So final point, our next OpenStack Summit will be much closer to all of you. It's going to be in Berlin in November at the CityCube Convention Center. So this is the closest the summit has been for a while, and closest it'll be for a while. So please come out and visit. One of the things that we do at the summits that's really valuable is called Upstream Institute, and again, that's something that a number of the people here are involved in organizing and teaching. And it's Upstream Institute is basically it kind of happens before the summit, and it's a boot camp on how to get involved as an upstream open source developer. And it's based around OpenStack, but it teaches a lot of useful concepts if you want to get involved in open source in general. So and that's something that anybody can do. I think we have a Nova Core here in Hungary as well. people who are interested in any of these topics, edge or containers or virtualization, there's space for you to join these communities and really have an impact. So come to Berlin and go to Upstream Institute if you're interested in that. And I'll be here throughout the day. I'd love to meet you all and answer any questions that you have. And now I will turn it over to the VP of Engineering at the Openstack Foundation, Thierry Carrez.